So let's welcome our two new students this week. This week, one of the things that we're going to be looking at is applications of linear functions. So we're going to look particularly at both one function, so one equation, and then we'll also look at some systems of equations examples. So in order to sort of go through linear applications, the best way to do this is just go through a lot of different types of examples. So I have like 15 or 16 examples. We'll get through a reasonable amount, and what I will do is, so here are examples of linear applications. So just because of the way that our whiteboard works, what I'll do is I'll write the number, and then we'll work it through as a problem. And when I post the board notes, I will put this as the first thing on the board notes, and then the work that we do will go below it, okay, so that you'll have access to the problems. And the advantage of this is also that at any point you can stop the tape, you can try and do a problem yourself and see if you get it correct, and then start the tape again to see us kind of work through it, okay? So you'll have a lot of opportunities to try this on your own. So these are mixed in, whether we're dealing with one equation or two equations, or I mix them all together. So in some of these it might be one, in others it might be two. Okay, so let's take a look at these problems. And I'm going to try and keep both of these screens open, and hopefully it won't cause too many problems so that you can see the problem that we're working on simultaneously as we do the work. So let's take question 1. So first of all, before we even start this, let's just go and talk about how to approach these problems, the steps that you might want to follow, okay? So how do we go about solving these? Are really word problems. Okay, and there is a step-by-step process that you can follow, and I apologize for the way that this is shifting. Unfortunately, I can't seem to make the side window go away, so that may mean that it shifts a little bit. I'm just gonna double check that there's nothing I can do. Oh, it seems like there's nothing I can do about that. So we'll do the best that we can. Hopefully it won't become too annoying. Okay. So it is a step-by-step process. The first thing that you want to do is you want to make sure that you read the problem. Okay. And as we go through these problems, we will go through these steps. So if any of these steps seem confusing to you right now, that's probably just because there is no problem that we're actually working with at the moment. The second thing that you want to do is you want to assign variables. So these are your unknowns, right? So you give them a variable. It could be X, it could be Y, it could be any letter. The only letter that we typically do not use, so we actually have a few, so I don't mean only. The letters that we don't like to use are I. So in one of the lessons in the very near future, you'll understand why, but I is an imaginary number. So you don't want to confuse I with something that's imaginary. We tend not to use O because it could look like a 0. And E, because E is actually a number, which later in the semester you will see. Okay, so I, O, and E. Some people try and avoid L just because an L could look like a 1 sometimes. So just choose your letters wisely. The third thing that you're going to do is you're going to reread the problem. You always want to reread so that you can interpret it correctly. And you can write your equation. Now I'm going to put the S here in parentheses because there may be more than one variable. Sometimes there isn't. Same thing with the equations. Sometimes there's more than one. Then you're going to solve. Sometimes you'll be solving a system. Sometimes you'll just be solving a regular equation. So once again, I'll put the S in parentheses. You're going to write your answer. And this is important because when you write your answer, you want to make sure that it's clear what numbers correspond to which variables, particularly when you have two of them. Then you're going to reread the problem one more time. And you want to check your answer. Sometimes this is just checking to make sure that your answer is reasonable. Okay, and as we go through these different problems, I will give you examples of when this may or may not be reasonable answers. Okay. Okay, so let's get started. I'll try and keep this video under an hour. Okay, and whatever we don't finish in the hour, I don't think it'll take us an hour to get through it, but just in case, I will. For any of you who want it, I can provide answers to the remaining problems. Okay. So let's start with the first one. And the first one you'll see in a few different ways. The first and the second are similar. So let's read the problem. One number is 5 more than twice the number. The sum of the numbers is 38. Find the two numbers. So we read it. Now we want to assign the variables. The variables are the things that we don't know, okay? So these are our unknowns, or what we're looking for. And I could tell you that in these problems, the things that we are looking for are usually identified in the last sentence. So this says, find the two numbers. We got an extra line here. Find the two numbers tells us that those are our unknowns. And the fact that we're finding two things, okay, that tells us we have two unknowns. So remember, when you have two unknowns, you're going to have two equations. When you have one unknown, you're going to have one equation. When you have three unknowns, which you're not going to see here, okay? But when you have three unknowns, you would have three equations. So here, these are our examples. So example 1, okay? Let's just call our two unknowns x and y. So x is equal to one number, and I'm going to abbreviate number with this number sign. It's called a pound sign. Some of you know it as a hashtag, okay, but it means number. And our y is equal to our second number. Okay, so we assigned our variables. Now let's reread the problem and write the equation. So one number is 5 more than twice the number. The sum of the numbers is 38. We have two equations here. We know that because we have two unknowns. Each sentence gives us an equation. So the sum of the numbers is 38, gives us one equation. So I'm going to underline this. This is one equation. Sum of the numbers, what does sum mean? That's addition. So one equation is x plus y is equal to 38. That's the easier one, okay? This one number is 5 more than twice a number is a little bit harder. And the way that we work through this is actually by working backwards. So I'm going to put that in here. So we work backwards through here. Okay, it's a little slanted. I apologize for that. We work backwards through the sentence. Okay, so what are we saying? We're saying twice a number. Okay, twice a number comes first. This is the first thing. So what is twice a number? First of all, it doesn't matter which number we're talking about, whether we're talking about x or y. But twice a number is 2 times that number. So we have 2x. Then we have 5 more than, right? So 5 more than, I'm going to move this arrow down now that it's all crooked. Okay, I'm not going to take the time to fix the way that it's coming out. But we have 5 more than. This is the second piece. What is 5 more than? 5 more than is plus 5. More than is plus. So 2x plus 5. So notice we worked backwards. We did the twice first, and then we did the 5 more than. The is an equal sign. Okay, that's what is. Is equals. So we have one number is 5 more than twice the number. And by the way, if you had written x equals 2y plus 5, that would have been absolutely fine. Okay, so I just chose to put the x on the where we use that as the number that was being multiplied by 2. Okay, so 2x plus 5 is equal to y. This doesn't really look like a 5, so I'm going to rewrite it. But I'm rewriting the same exact thing. It just didn't come out looking like a 5. Okay, a lot of times it comes out perfectly on my paper, but then I look at the screen and it doesn't look the same. Okay, so we wrote the equations. Now we need to solve for the variables. Well, we have 2 equations. This is a system. One of them is already solved for a variable. So if you remember from systems of equations, we decided that we could use substitution here. You can absolutely use elimination. I'm going to use substitution. Okay, so now we solve. So this 2x plus 5 can get substituted for this y. So now what we have is x plus 2x plus 5 is equal to 38. So notice what we did. We took the first equation and we replaced the y with 2x plus 5. Now these parentheses are there to show you that we replaced the y with the 2x plus 5, but they actually come second and it's all addition. So these parentheses still aren't really needed. So we have x plus 2x plus 5 is equal to 38. And now it's a matter of solving. So we combine like terms. 3x plus 5 is equal to 38. We can solve for x. This is a linear equation. So we can subtract 5 from both sides. This gives us that 3x is equal to 33. And then we divide both sides by 3. Okay, and we get our answer. We get that x is equal to 11. But remember what we have to do. It says find the two numbers, okay? So if we find the two numbers, that means that we're finding both x and y. And we can use either equation to do that. So we can use the first equation or the second. Both of them I think are equally easy in order to find y. But since the 2x plus 5 is already solved for y, we may as well use that. You can absolutely use the other one. So this gives us 22 plus 5, or 27. Okay. Okay, so now if we look at this and we go back to the we go back to our list of steps. It says once we read the problem and write the equation, we solve for the variables. Now we write our answer, okay? Now this has to do with clarity. I'm going to change this just a little bit. Okay. So this has to do with clarity, right? Writing your answer. So you're not really writing this as a coordinate because we're not really talking about graphs here. We're talking about two equations and we're finding one number and another number. There are two different ways to write your answer, okay? If you write this very clearly, you tell us what x and y are, then all you have to do is say, okay, x equals 11, y is equal to 27. And that's pretty clear. If you do not have a statement like this, in other words, nowhere in your answer do you say what x is and what y is, then you have to write out some sort of sentence. So the sentence here would be the two numbers are 11 and 27. That's what we mean by write your answer. We want to make sure that we're being very clear. Okay, so that would be it. The next thing would just be, I'm sorry, this is annoying that it goes like this. I'm gonna see if I can fix it. So the next thing is reread the problem and check your answer. So this says one number is 5 more than twice a number. So twice 11 plus 5 is 27. The sum of the numbers is 38. 11 and 27 is 38. Okay, so we checked our answer. Okay, the sum of the numbers is 38. The other thing that you can look for is the reasonableness of the answer. So for example, I've gotten students who will put 11 and 39 because they're not really thinking about what the problem is saying, which is why we say reread the problem. And because of that, their answer doesn't make any sense, right? If it says the sum of the numbers is 38, it doesn't make sense for one of the numbers to be greater than 38, particularly if neither of them is negative. Okay, so that's what we mean by check the reasonableness of the answer. Does it make sense, or is the answer kind of ridiculous? Okay, and in a lot of cases, you'll look at it and you'll say, oh yeah, it actually is ridiculous. Okay, and this would be it. This work is exactly what we would be expecting to see. Okay, okay, so let's go to the next one. So we should be able to work through this next one a little bit faster now that we've sort of gotten into the swing of things. Okay, so the next one says, we're going to read it. The sum of two numbers is 62. One of the numbers is 6 more than 4 times the other. Find the two numbers. So very similar to number 1. So once again, we're going to assign our variables. So it says find the two numbers. Remember, the last sentence is our unknowns, okay? So find the two numbers. We can use x and y again. X equals, I'll say first number, it kind of makes more sense. Y is equal to the second number. You can use m and n if you prefer. Okay, so we found that. Now we want to find the equations. So we're going to reread the problem. The sum of two numbers is 62. One of the numbers is 6 more than 4 times the other. So we have two sentences. Sum of the two numbers is 62. Okay, that gives us our first equation. Sum is addition, so x plus y is 62. And the second one, remember, is the one that moves backwards. And our arrow actually goes on the other side. Let's just redo it so that it's correct. Okay, so we go backwards. That's really the key to this sentence, is always go backwards, okay? So 4 times the other. So 4 times is multiplication, okay? So we're going to do 4. And let's use y this time. Then the next thing that we see is 6 more than. So more than is plus. And then we see the word is means equal, and one of the numbers. So equals x. So again, you could have absolutely said 4x plus 6 is equal to y. That would have been absolutely okay. Okay. So we have these two sentences. Each sentence is an equation. Okay. Now we solve the equations. So when we solve these equations, again, it's a system. So we can use elimination or we can use substitution. This one, it kind of makes more sense to use substitution, but if you wanted to use elimination, you can. So we do a substitution just like we did the last time. The only difference is that this time we're going to substitute for x. So 4y plus 6 is the same thing as this x here. You don't need the parentheses. If you want to put them in the beginning, just so that you see that that's what is replaced, that's what replaced x, that's fine. But it's the very first thing in the equation, and everything is addition. So it's absolutely fine not to put parentheses in. Okay, now it's just a matter of combining like terms. We have 4y and y. So we have 5y plus 6 is equal to 62. Then we subtract 6 from both sides. Sorry, I wrote, no, that's right. Okay. So we get 5y is equal to 56. Okay, then we divide both sides by 5. And this is a case where you would want to switch to decimal. Okay, and the reason why you can switch to a decimal and not leave it as a fraction is that when we divide something by 5, we get perfect decimals. Okay, they don't go on forever. And what we get for y is 11.2. Okay, and then we solve for x. So again, you can use either equation. Okay, some of you are going to feel it's easier to just do 62 minus 11.2. Some of you are going to feel it's easier to plug it in here. Let's plug it in there. 4 times 11.2 plus 6 and we get 50.8. Okay, so we can write this in one of two ways. We can write our answer in one of two ways. We can either just say, okay, x is 50.8, y is 11.2, or we can say the two numbers are 11.2 and 50.8. Either way is fine with me. If you don't write x equals y equals, then you have to write the sentence. Okay, and if we add 11.2 and 50.8, then we do get 62. Okay, and we already know that 4 times 11.2 plus 6 is 50.8. Okay, so hopefully now you're a little bit more comfortable with a problem like that. So remember, each sentence gives you an equation. One of the sentences, you're going to be going through it backwards in order to give you the second equation. Okay, let's do question 3. So question 3 is a little bit different, and you're going to see a lot of very similar questions to question 3. Okay, so let's read through it. A total of $17,000 is invested in 2 accounts. That means essentially you go into a bank and you have $17,000, and you're saying to the teller or the bank manager that you want to put some of that money into one account and the rest of the money into the other account. Now, when you go into a bank, in a lot of accounts, you get interest, okay? Meaning that if you leave your money in that account, you're going to earn some extra money based on how much is in that account. So one of the accounts pays 5% interest per year, and the other account pays 6.5% interest per year. Now, the total interest, meaning forget about the $17,000, you're just talking about what you earned on top of the $17,000, is $970. How much money was invested into each account? Okay, so we need to assign our variables first. So remember what we said. We said that the last part tells you your variables. So this says how much money was invested into each account. So we're going to assign our variables. So again, we can use x and y. You can use something else if you want. So we're going to say let x equal the amount of money in the account with, so with can be abbreviated with the W/, with 5% interest. So you have to be really clear here. And you have to remember that x is a value. So you can't just say account with 5% interest. X represents the amount of money in that account. And that's important because I will take off a half point for that. X represents an amount of money, okay? You can't just say it's the account. It's not the account. We don't call it account X and account Y. We're saying that X is the amount of money in the account. So your X and Y is always an amount. Okay, and Y is the amount of money in the account. You can feel free to abbreviate account ACCT with 6.5% interest. So these are our two variables. Okay. Now let's reread this problem. A total of $17,000 is invested in two accounts. One of the two accounts pays 5% interest per year, and the other account pays 6.5% interest per year. If the total interest paid is $970, how much money was invested into each account? So we have the amounts of money in the two accounts add up to $17,000, okay? So one of the accounts has a certain amount of money. The other account has a different amount of money, each adding up to $17,000. So that is one equation. X plus Y is equal to $17,000. Because remember, the X is the amount of money that you're putting in the account before earning interest. So we're not worried about interest yet. Now we have one of the accounts pays 5% interest, the other pays 6.5% interest. Total interest is $970. So now we have an equation where we have interest plus interest equals total interest. Well, the total interest is $970. The interest in the first account with 5%, well, in order to find 5% of the money in the first account, we take the amount of money in the first account and we multiply it by 0.05. And in the second account, it's 6.5% interest, so we multiply it by 0.065. You divide by 100. Okay, so these are our two equations. Interest plus interest equals total interest. That's how we get that second equation. Okay, 0.065 is 6.5 divided by 100. The 0.05 we got from doing 5 divided by 100. That's how we turn a percent into a decimal. Okay. Okay. This is the hard part of these problems, is coming up with the equations. Once you have the equations, it's easy to solve. Okay. So you have a few options here. These are both in standard form, right? You have your x's and your y's on one side and your constants on the other. So you could solve with elimination. I actually find this easier to solve with substitution. The reason why I find that so much easier is that it's so easy to solve for one variable, okay? So the variable that I choose to solve for is usually the one with the smaller percentage. You'll see why in a second, but it absolutely does not matter, okay? So in other words, the 0.05 is next to the x. The 0.05 is smaller, so I'm going to solve for x, okay? And what we get when we solve for x is that x is equal to 17,000 minus y. So we can just subtract y from both sides. And then what we get is 17,000 minus y is going to be substituted in for the x in the equation with interest. So we get 0.05 times 17,000 minus y plus 0.065 y is equal to 970. Okay, and the next problem is actually very similar to this one, so you're going to see this happening again. So you'll get the hang of it the second time around if you haven't gotten the hang of it yet. Okay, so we have our amount of money in each account. That's the total amount invested. Then we have the interest plus the interest is equal to the total interest. Okay, so we have our two equations. You see total here and you see total here, right? On 3, you see total in the first sentence and total in the second sentence. So you know that you're talking about a sum. You also know that the 17,000 is on one side of the equal sign in one equation. The 970 is on one side of the equation, is on one side of the equal sign in the other equation. Okay, now it's just a matter of solving. So this is pretty straightforward at this point. We know we get rid of the parentheses first. Okay, When we get rid of the parentheses, 0.05 times 17,000 gives us 850, which is completely reasonable because it should be around 970. It should be relatively close to this number here. You'll see why in a second. Then we have 0.05y plus 0.065y is equal to 970. We combine like terms, and this is why I like to solve for the variable that has the smaller number in front of it, the smaller coefficient, because now we have negative 0.05 plus 0.065, and that leaves us with a positive value in front of y. This gives us 850 plus 0.015y is equal to 970. If you had gotten a negative number, it's no big deal, okay? This just keeps it positive. It's a personal preference. Now we subtract 850 from both sides. $970 minus 850 gives us 120, so we have 0.015. Y is equal to 120. We divide both sides by the 0.015. And we get 8,000 for y, which is absolutely reasonable, right? I'll put that in blue. This is an absolutely reasonable amount. It's less than 17,000. If you did not convert your percentages to decimals correctly, you are going to get some crazy number. So you might get something like 0.08 or something like 800,000. You know that that's unreasonable because the total amount of money invested is 17,000. So you can't get that in one account you put 800,000. It doesn't make sense, okay? And then your x is equal to 17,000 minus 8,000 or 9,000. Okay, and this is where having this let statement makes your final step easier, because I am okay with your just writing this is $9,000 in account X, and in account Y you have $8,000. I am absolutely okay with your doing that. Now, some professors are really particular and they'll say, in the account with 5% interest, you have $9,000. And in the account with 6.5% interest, you have $8,000. I don't feel a need to make you do that because I feel that when you write it in this way, it's very clear. Okay? So I'm not a stickler for that as much as some other professors are. And that's it, you're done. Let's do the next one, which is similar, very similar. So you'll notice it says a total of 11,000 is invested in 2 accounts. One of the 2 accounts pays 9% interest per year, and the other account pays 11% interest per year. If the total interest paid is $1,150, how much was invested into each account? Practically the same problem, just with different numbers. So our 2 variables could still be X and Y. This time, this is the amount of money in the account with 9% interest. So notice I abbreviated account with the ACCT. I really want you to have these let statements, not only because it makes your answer easier to write, but it also makes your work much clearer, Okay, everybody knows what your X and your Y stand for. And because of that, if I wanted to reproduce your work, okay, or I was looking at this problem to help me figure out the answer to problems that were just like it, this makes sense, okay? I know what the X and the Y are. If you wait until the very end, it's not as clear, it's not as elegant. So you really want your let statements in there. So that's what I'm a stickler for. Okay, so we have the same thing, right? We have the total invested. So this says a total of 11,000 is invested. So we have X plus Y is equal to 11,000. Then we have interest. So remember, interest plus interest equals interest. So this says one account has 9% interest. So to get 9% interest, you multiply by 0.09. The other account gives 11% interest. And the total interest paid is $1,150. So total is a sum, and it's equal to $1,150. Now we're ready to solve, okay? So again, I'm going to solve with substitution. I do believe it's a lot easier here. You don't have to. You can also take this second equation and get rid of the decimals by multiplying by 100. So if you had 9x plus 11x equals 11,500, that would be okay too, okay? So this, I'm going to solve for x because x has the smaller value in front of it. So x is equal to 11,000 minus y. Now we do a substitution. So this x is going to be replaced. So we have, I'll keep this in blue, 0.09. And now we have 11,000. I'm sorry, I wrote y here. I wrote x. That's really a y. It didn't come out looking like a y. Okay, sorry about that. So 0.09 times 11,000 minus y. That replaces our x. Plus 0.11y is equal to 1150. From here, once we substitute, this is just our basic solving, right? Get rid of parentheses first. So 0.09 times 11,000 gives us 990. Then we have minus 0.09y plus 0.11y. And negative 0.09 plus 0.11 is 0.02. So we have 990 plus 0.02y is equal to 1150. Okay. Subtract 990 from both sides. So this is stuff that we've done before. So 1150 minus 990 is equal to 160. Sorry, I meant to put that in blue. I used the different colors so that you could tell apart what is just work. Then we divide both sides by 0.02. And remember, we're looking for the reasonableness of the answer. And what we get is 8,000 again. And 8,000, once again, is reasonable, right? It's less than 11,000. It's positive. If you were to get a negative number, that would make no sense. You can't put a negative amount of money in an account. So our final answer is that y is equal to 8,000. Okay, but remember, we also have to find x. So x is 11,000 minus 3,000. Sorry, minus 8,000, which is equal to 3,000. And you could write your final answer as a sentence, or you could say the amount in the account with 9% interest is 3,000. The amount in the account with 11% interest is 8,000. Okay, just make sure that you assign the right thing to the right account, right? So you solve for x is 3,000, make sure that you actually assign it to the x. Okay, and that's number 4. Okay, let's take a look at number 5. Number 5 is actually very similar, okay? There's very little difference between 4, 5, and actually even 6. So number 5, it says, at Mo Math Museum, tickets for adults cost $9 and tickets for children cost $4. If 350 tickets are sold for a total of $23,050, how many adult tickets were sold and how many children tickets were sold? Okay, so it's phrased in a slightly different way, but it's essentially problem 4. Here's why. First of all, we identify our variables. So our variables are usually told to us in the last sentence. How many adult tickets were sold? How many children tickets were sold? So let's let A equal, we don't want to just say adult tickets sold, we want to say the number of adult tickets sold. And C is the number of child tickets sold. And this says 350 tickets are sold. That makes our first equation very simple. 350 if you put together the adult and the children tickets. Okay, so tickets plus tickets equals tickets. That's your first equation. The second equation is money plus money equals money. Right? The second thing that we're told is stuff about money. So all of the stuff about money stays together. So think about it. It tells you the cost of adult tickets and it tells you the cost of children's tickets. So how much money did we make in total from the adult tickets? Well, each adult ticket is $9. And we have A adult tickets. So what we can do is we could just say, okay, well, the amount of money that we make from adult tickets is 9 times A. Now we do something similar for the children's tickets. Each child ticket is $4, and we have C of them. So the total number, the total amount of money that we make is 4 times C. So this is the money made from the adult tickets plus the money made from the children's tickets equals total money. So your totals are in 2 separate equations. Don't try and combine it. Now this is exactly like the other equation. So we could solve this using substitution. I'm going to show you how to solve it using elimination just to do something a little bit different, but you can absolutely use substitution. Okay, so we don't have any decimals here, so elimination is just as easy. Let's multiply this whole thing by -4. Why are we multiplying by -4? Because I see a positive 4C. So I want to make it this, a -4C. And I could do that by multiplying by -4. I also could have multiplied by -9, and I would have eliminated the a instead, but then I'm dealing with a much larger number. Okay, so I kind of prefer this. So what do we get here? We get two equations. We get -4a minus 4c is equal to, and we multiply 350 by -4, and we get -1400. Then we have 9a plus 4c is equal to 2350. And if you remember, we add the two equations. Okay, -4a plus 9a gives us 5a. The 4c's cancel. And -1400 plus 2350 gives us 950. So now we could find a. We divide both sides by 5. $950 divided by 5 is 190. And then the number of child tickets is just 350 minus 190. Which gives us 160. And remember, we're looking for the reasonableness of our answer. So 190 is really where we're checking the reasonableness. And 190 is perfectly reasonable. Okay, it's under the 350. That's really what we're looking for. If we mess something up, we might get a number much greater than 350. Okay, or a number really, really tiny where it wouldn't make sense. So this makes sense. So now we could just write in. We could either say we sold 160 child tickets and 190 adult tickets, or we could just write it in here. So A is 190 and C is 160. And that's our answer. That's it. So that's number 5. Let's take a look at number 6. Okay. Number 6 says, at the Bronx Zoo, tickets for adults cost $28. Tickets for children cost $13. If 550 tickets are sold on Saturday for a total of $12,700, how many adult tickets were sold and how many children tickets were sold? Very, very similar, practically identical, right? We're just talking about the zoo instead of the museum. So we're going to set up our equations again. So we'll say let A equal the number of adult tickets again. We'll say let C equal the number of child tickets. So notice we're not using X and Y. That's absolutely fine. And we have essentially the same equations, right? Tickets plus tickets equals tickets. 550 tickets are sold. A plus C is equal to 550. Adult tickets are 28. Children tickets are 13. Total is 12,700. So we have 28A plus 13C is equal to 2,800. Okay, and let's do this one using substitution again. So in our substitution, this time I'm going to solve for C because C has the smaller number in front. Remember, that just leaves everything positive. That's the only advantage to it. So C is equal to 550 minus A, which means we have 28A plus 13C, C is 550, minus A is equal to 2800. So we substituted this C. And then we just distribute. So we get 28A plus, we're going to do 13 times 550, and we get 7,150. I'm so sorry, I messed this up and I put 2,800, but 2,800, I got confused. So this is 12,700, right? I apologize. I just realized, the way that I realized I made a mistake is that the 7,150 didn't make sense. That meant that we were making more from the children's tickets than from all of the tickets together. That didn't make any sense, okay? So I don't know where I got the 2,800 from, but that was clearly wrong. Meant to say 12,700. So then we have plus 7,150. This makes more sense. So notice you're constantly looking at whether things make sense. Minus 13A. And we have 28 minus 13 is 15A. I should write the whole equation. 12,700. And then down here, we could write 15A plus 7,150 is equal to 12,700, right? The 7,150 is less than 12,700, which makes sense. So we're going to take the 12,700 and subtract 7,150. And we get 15A is equal to 5,550. Divide everything by 15. That gives us our A. So A is equal to 370. And that means that C is 550 minus 370, which gives us 180. And remember, we just write in the answer up at the top, right? Number of adult tickets is 370. And the number of child tickets is 180. Okay, so in the interest of time, I'm going to skip number 7 and go to number 8. 7 and 8 are exactly the same, okay? I'll do number 7 and skip number 8, okay? They're exactly the same, just like 5 and 6 were exactly the same, just change of numbers. I just want to get through one of each type of problem, and then I'll post the answers for the others. I just don't want this video to be overwhelming for no reason, okay? So number 7. Again, this is just like the others, very similar. It just has this one added piece that some people might get confused about. So I just want to go through it and show you it's really no different, okay? So this says, how many gallons of 20% alcohol solution and 50% alcohol solution must be mixed to get 9 gallons of 30% alcohol solution? Okay, Seems like it would be very hard. It's actually not. First of all, we have our unknowns. It says how many gallons of 20% alcohol solution and 50% alcohol solution. That's the unknown. See, it's in your question, okay? So let's use X and Y again. You don't have to, but I know that's what you're familiar with. So X is gallons of. Remember, it's not alcohol solution, it's gallons of. 20% alcohol solution. I'm going to abbreviate just with SOLN. And that means that Y is the gallons. Oh, I'm doing 7. So notice I don't really have to change anything. The difference is that we're using 25% antifreeze and 50% antifreeze. So nothing really changed, right? Y is gallons of 50% antifreeze. We're doing number 7. Okay. 8 would just be 20% alcohol solution, 50% alcohol solution. Now we have to come up with the equation. So it says that when we combine these, we should get 40 gallons. So that gives us our first equation. X plus Y is equal to 40. The second equation is the slightly tricky part because it's antifreeze plus antifreeze equals antifreeze. So the amount of antifreeze in the first solution is 0.25x. In the second solution, it's 0.50x. And in the final solution, the total antifreeze is 0.30 times 40. Okay? Because the 0.30 is the fact that 30% of the total is antifreeze and 40 is the total. So you have to do this extra calculation just to get what it's equal to in that second equation. Okay? And 0.30 times 40 is 12. Okay. Okay. So now this isn't bad. Let's solve this using substitution. I'm only choosing substitution because they're decimals. That's the only reason. So we're going to solve for x because x has the smaller coefficient in the second equation. So we say 40 minus y, and I'm going to crush this in here a little bit, but if it gets too tight, then I'll just move on to another page. So that gives us 0.25 times 40 minus y is equal to 0.50, plus. I did the same thing again, didn't I? It should be a y. Plus 0.50y is equal to 12. We distribute. Notice it's always the same process. It gets a little tiring, right? But it's always the same, which makes this really simple. So 0.25 times 40 is 10. Negative 0.25 plus 0.5 gives us plus 0.25. Okay, we can subtract 10 from both sides. We get that 0.25y is equal to 2. and we divide both sides by 0.25. And what we get is that y is equal to 8. And if y is equal to 8, then x is 40 minus 8, or x is 32. And we can just write that up at the top. So x is 32 gallons, y is 8 gallons. Okay. Now I won't do number 8. I'm going to skip number 8. And we're actually going to skip a bunch of these because they are very similar, like the ones particularly 14, 15, 16, 17 are great examples that you can do on your own that are very similar to what we've done already. I will say a nickel is 5 cents and a quarter is 25 cents for anybody. I know that there's some of you who haven't been in the country that long, so you might not know that. Okay. Okay. Let's do number 9. Okay. So some of these will go much faster, and I realize it's an hour and 6 already, and I wanted to keep it under an hour. So we're not going to solve all of the equations. Okay. I'm going to give you the equations, and then you can solve them on your own. Again, I just don't want this to be too overwhelming, just going through problem after problem. So in number 9, Jose bought a pay-as-you-go phone. He sent a total of 25 picture messages. Actually, I'm going to skip this one because it's very similar to the last one. Okay, we have total messages, so we're going to have x plus y equals 25. Then we have total amounts, so we're going to have something equal to $6.38, and it's 0.14 for the text, so 0.14 t plus 0.32 p is equal to 6.38. Those are our two equations, right? P plus t is 25, 0.14 t plus 0.32 p is $6.38. Okay, so let's go to 10 because 10 is a little bit different. Okay. This says New Jersey's transit annual passenger revenue for the years 2007 to 2017 is modeled approximately by the formula, and then it gives us this very nice little formula, where R is the annual revenue in $1 million, okay? And it acts as the number of years since 2002. In what years was the passenger revenue 722 million? So it's telling you R is 722, okay? Because remember, this says revenue in $1 million. So we don't say 722 million for R, we say 722. So this is our equation, and notice this is one equation. 722 equals negative 60 times the absolute value of 2x minus 11 plus 962. So quickly, we're going to solve this absolute value. Okay, we subtract 962 from both sides. $722 minus 962 gives us negative 240. Which is equal to negative 60 times the absolute value of 2x minus 11. Okay. Then we divide both sides by negative 60, which makes sense because remember, an absolute value cannot equal something negative. So we get 240 divided by 60. We get a 4 here, so 4 is equal to the absolute value of 2x minus 11. Okay, this is an absolute value equation, so please keep in mind absolute value equations yield two linear equations. 2x minus 11 equals 4, and 2x minus 11 equals negative 4. Okay, now just in the interest of time, I'm just going to give you your answer here. If we solve this, we get 2x equals 15, or x equals 7.5. Here we get x equals 3.5. So keep in mind that we got two answers here. So the answers that we got are the number of years since 2002. 3.5 years since 2002, and 7.5 years since 2002. So our answer is, in the years, 2002 plus 3.5 is 2005.5. So 2005, 2002 plus 7.5 is 2009.5, and 2009. Okay, so that would be 10. Okay, let's take a look at 11, and we'll take a look at 12 as well. Okay. So 11 says, Sonica weighs 190 pounds. If she loses 5 pounds for a month by diet and exercise, when will she weigh less than 160 pounds? So this is linear, okay? It's linear because we only have one variable, the weight, right? Okay, it's an inequality in this case because notice it says when will she weigh less than 160 pounds? So she starts off at 190. She's losing 5 pounds per month. So we want to know when 190 minus 5 times x is less than 160. Okay. And we want to know when is she going to weigh less. So again, I'm just going to give you your answer here. Okay. You subtract 190 from both sides, you're going to get negative 30. And then you have to divide both sides by negative 5. So you get that x, and remember your inequality switches, x has to be greater than 6. Okay, 30 divided by 5 is 6. And because we divided by negative, because we have the negative 5 in front of here, this inequality flipped. So after 6 months. Okay, and let's just take a quick look at 12. The revenue for selling N dresses is R equals 84.95 N. The cost is 4,580 plus 42N. So we're given two equations. Find the number of dresses that the company needs to sell to produce a profit. So the profit is when R is greater than C. So that's the equation that we're setting up. We want to know when 84.95 N is greater than 4,580 plus 42 N. That's what we want to know. That's what the profit is. Okay? The profit is when the revenue, what is coming in, is greater than the cost. Okay? And this one, again, I'm just going to give you the answer here. We have to subtract 42N from both sides. That gives us 42.95 N here, okay? And then we just divide both sides by 42.95. So if we do that, we get N is greater than 106.64, but obviously we can't make 106.64 dresses. So the answer is when we, or the company, sells 107 dresses. Okay. 13, I want you to try on your own. It's not that simple. You're going to wind up with a compound inequality that you then have to break up. The only way to solve it is with two separate inequalities. It's one of the only times that compound inequality, you're going to wind up with variables on both sides. And because you have variables on both sides, a single variable, okay, on both sides, you should split it up in order to solve it. So I want you to try that on your own. Other than that, the rest are essentially ones that you've already done, just in different forms. Okay, so I will give you the answers. I'll post them sometime in the next few days when I post the video. Okay, and that's it. So see you next time.